understand this, okay, I'll just explain what is going on here. So you have positive number of xn. You don't know what's this one, you do not know what is the seed value. So you don't know what is x1. So meaning when it starts, but doesn't matter. Basically, say, for example, if say my first term is 1, okay, then my x2 will be, I essentially follow this rule, right? Is root 6, 6. Okay. X3 will be what? X3 will be root 6 plus 5. Then I'll get this value here. Okay. So you just, to get the next term, you take the current term plus 5, then square root it. So this case, I take 1, I sub inside here, plus 5, then I root it, I get x2. Then if I want to get x3, I just sub inside here, then I plus 5, I get this guy. Okay. Then if I want to get x4, this will be the entire thing here. Root 6 plus 5, plus 5. This is my root, my x4, and so on. You can go on. So that this is the recurrence relationship you are looking at. But you do not know what is this x1, because you're not, it is not given to x1. Can be anything. You can define it, the starting point, as what. It doesn't matter. Okay. But so we look at the first one. Okay. We do not know what it is, but as n goes to 0, infinity, meaning at some juncture, you x1, x2, x3, all the way to xn here, xn plus 1. This tells you that converges to L. Because this guy will be L, this guy will be L. Subsequently, I know the series will all be L behind here. It will all be L, confirmed, because that's what it's saying. It just converges to L. In any order, as n goes to infinity, xn goes to L, you know xn plus 1 will also go to L. Alright? So essentially, right, xn plus 1 equals to xn plus 5. This will become L because everybody converge to L. Then this will be L plus 5. Okay? So this is L squared equals to L plus 5. I think this is a golden ratio. You just solve for L. Shouldn't be an issue, right? You solve for L. This will be minus 1 plus minus B squared minus 4AC 2A. Minus 1 plus minus 1, 5, 20. Oh, it's not the golden ratio. 20, 19. 20. 21. Fifth one, because they say positive number will grow. The Akong say one, not I say one. Okay, the question say it's positive number, so you just reject as L is a positive. Okay, they are all positive values. So this is root 21 minus 1 over 2. Careless. It's minus 1b, so this is plus. Prove that xn plus 1 square minus L square is equal to xn minus what L lah. Okay, so what you need to do is the left hand side. Just use the difference in squares, right? This is just be our favorite xn plus 1 minus L, xn plus 1 plus L. Okay, this one should be okay. Essentially, this will not work anything, right? But because I know that I need to change this xn to xn plus 1 to xn. So previously, we know that xn plus, given in the question, is xn plus 5. So we know that xn plus 1 square is xn plus 5. Then I can substitute this. I just want to change to xn. So from here, I can just sub it in. So this will be xn plus 1. Xn plus 1 square will be xn plus 5. Okay, this guy. L square is this guy. This guy here. L square is L plus 5. you repeat L plus 5 inside, so this guy will be minus L plus 5. It is okay. This is just basically just treasure hunting. Just go and look for the things that you want. So this is right hand side. Okay, I don't look at part 3. So part 3 a bit not easy, but we try and slowly digest. So sure that if this happens, right, then it will imply that xn is bigger than xn plus 1 is bigger than L. What does it mean? What does this mean? Can you explain to me what is this trying to tell you? It tells you what? It's decreasing, right? Can you tell me it's decreasing? Because if xn is bigger than if this is a current term, this is the next term, this is the limit. Xn is bigger than the next term, then subsequently it will be bigger. So it's actually decreasing. You don't go into this like a headless chicken. Try to understand what you're trying to say. So the xn, the current term is bigger than the subsequent term. So and then it's bigger than the limit. So that's what they're trying to say. Okay. So we slowly start from the first part, which is what was given. Part 3. This one, xn and L. So we know xn L. What do we do? For any kind of inequalities, what we should do is make one side 0 lah. Okay. So then from here, but why? Because this would xn minus L from the second part is this guy says xn plus 1 square minus L square is bigger than 0. So this is from 2. This part is useful because this is difference in square. Like that, bigger than 0. This one tells you what? That this entire thing is positive. Alright? I don't care what you do. This tells you these two factors, when I multiply them, this entire thing is confirmed positive. First thing. Second thing, we know that xn, these are all positive terms. Positive plus positive, we can for sure know that is positive. Understand? So I repeat, because every term is positive, I know that this will be positive. Okay. Why? Okay. Because overall is positive, have two possibilities, right? If overall is positive, either you have two factors which are positive, or you can have two factors being negative. Agree? So we want to ask ourselves, if overall is positive, we have two factors here. What is this? The first one. Is it positive or negative? That is the question lah. So because we know that this is positive, then confirm this is positive lor. We deduce by knowing. So hence, since you write this down, since xm plus 1 plus L is positive. Okay. Hence xm plus 1 minus L is also positive. That's how you write. First time doing this wouldn't be easy. So this is xn plus 1 bigger than L. Xn plus 1 bigger than L. We only do one side. We never do the xn is bigger than xn plus 1. We start with what we found just now, which is xn plus 1 square minus L square is equals to xn minus L, right? That's what we found. Then you just expand it out. Yeah. Okay, how do you understand this? So once you reduce this really, you see that this is xn plus 1 minus L, this is xn minus L. Similar, right? But what you need to understand is that this is xn plus 1 minus L is a fraction of xn minus L. like that. You see it as a fraction. So for example, right, you say, example, okay, here, if say k minus b is equals to 1/4 of q minus b, you can effectively say what? You can effectively say that k is bigger than q. Okay, so because this is 1/4, right? So you when you expand everything in, you realize that is 1/4 of it lah. So this k minus b, this is 1 minus q. So meaning k minus b is smaller than q minus b. So k is smaller than q lah. Okay, that's the idea. So I repeat you look at this one here. Okay, if you don't like this, right, it only happens, this is a fraction. So xn plus 1 plus l has to be bigger than 1. Alright? Because L just now was bigger than 1. The L here, this is 1. Okay. 1 plus root 2. Because, and they are always positive. So it's definitely root 2. This is root 21 plus 1 over 2. This is 2 point something. This is more than the L. So this will be more than L. Okay. So this is a fraction. So essentially see this as, you have to make sure that the denominator is bigger because if 1 over 0.2, this will be 20 okay, you need to make sure that this entire thing is more than 1, the denominator. So if it's the reason, it will only be a fraction when the bottom is more than 1. Okay, more than 1. So that's the case there. So if this is a fraction, so in other words, xn plus 1 is a fraction, right? Will be smaller than xn minus l. Xn plus 1 is smaller than xn. Combining 1 and 2, you have xn is larger than xn plus 1. Go.